The graphite grading scale. Structural carbon density. Pencils are calibrated from hard to black. Harder graphite leaves microscopic razor-thin structural lines. Softer, B-grade graphite deposits heavy, unyielding carbon particulates for maximum light absorption. The needed eraser. Particulate absorption. Standard rubber violently shears the paper's surface. This malleable putty relies on adhesive microfriction. Pressing it mathematically lifts and absorbs carbon particulates without destroying the paper's structural lattice. The blending stump, localized gradient shear. Also known as a tortillon, this tightly rolled paper cylinder exerts precise friction. It forcefully shears and spreads carbon deposits, transforming harsh structural lines into mathematically smooth, photorealistic gradients. The overhand grip, biomechanical pivot locking. Holding a pencil like a pen forces localized wrist fatigue. This grip locks the wrist, transferring kinetic motion to the shoulder, generating absolute sweeping geometric curves with zero mechanical restriction. Line weight calibration, optical depth manipulation. Uniform lines flatten a subject. By strategically varying the downward mechanical pressure on the graphite, the resulting line alters in thickness, forcing the human eye to perceive absolute three-dimensional depth. The vanishing point, planar geometric convergence. The human eye perceives depth through optical distortion. By locking a singular mathematical point on the horizon line, all parallel structural vectors converge flawlessly, creating vast three-dimensional spatial distance. The primary light source, photonic directional anchoring. A drawing cannot achieve mass without light. By establishing a fixed trajectory of incoming photons, the artist dictates the exact opposing angle of all shadows, locking the object into absolute physical reality. The core shadow, point of maximum photon deflection. This is the exact longitudinal axis where the object completely turns away from the light source. It is the darkest, most concentrated band of carbon, mathematically defining the unyielding spherical mass. The cast shadow, geometric light obstruction. When a solid object violently intercepts a light path, it creates a void of photons on the adjacent surface. This shape of the shadow instantly anchors the floating object to the ground plane. The plumb line, absolute gravitational alignment. To measure exact proportions, artists use a vertical axis. Extending a straight, unyielding line from the highest point calibrates all architectural features against true gravitational verticality. Negative space, structural void mapping. Amateurs draw the object, professionals draw the void around it. By accurately calculating the exact geometric perimeter of the empty space, the internal mass of the subject mathematically creates itself with zero error. The paper tooth, microtextural abrasion. Paper is a microscopic landscape of interlocking cellulose fibers. This texture acts as a highly abrasive file, violently shearing carbon from the pencil to allow massive, dense layers of pigment stacking. The contour line, topographical surface mapping. A standard outline defines a flat silhouette. Contour lines travel directly across the internal curvature of the mass, mimicking a three-dimensional wireframe to mathematically force the illusion of protruding volume. Crosshatching, intersecting linear density. Shading without smudging requires geometric layering. Stacking hundreds of perfectly straight, intersecting linear vectors mathematically blocks light reflection, generating deep structural shadows through pure optical mixing. The fixative spray, aerosol polymer sealing. Graphite is highly unstable under microscopic kinetic friction. This aerosol violently projects liquid acrylic resin, chemically bonding the loose carbon particulates permanently to the cellulose lattice upon contact. The chromatic wheel, visible light spectrum organization. Colors are specific radiation wavelengths. placing complementary wavelengths opposite each other creates violent visual contrast through mathematically calculated optical vibration. The wax-based pigment core, friction-induced chromatic deposition. Unlike graphite, these utilize synthetic pigments bound in unyielding wax. Aggressive kinetic friction melts the binder, forcing the pigment directly into the microscopic paper lattice. The alcohol-based marker, rapid chemical evaporation. The dye is suspended in a highly volatile ethanol solvent. Upon hitting the paper, the alcohol violently evaporates in milliseconds, leaving a flawless, translucent chromatic layer. The fine liner pen, hydrostatic capillary action. A highly engineered porous plastic tip draws microscopic liquid ink from a fibrous reservoir. It dictates absolute, unyielding line consistency regardless of the user's downward kinetic pressure. The synthetic brush pen, kinetic elasticity. Utilizing hundreds of microscopic nylon filaments, this tool mimics biological hair. It requires exact pressure modulation, bending under force to generate massive, instantaneous variations in structural line weight. The stainless eraser shield, surgical particulate extraction. Deleting specific graphite deposits without destroying surrounding data requires a mechanical barricade. This micro-thin steel plate isolates precise geometries, allowing aggressive kinetic erasure with zero collateral damage. The LED light board, translucent photon penetration. To duplicate structural data without measuring, a high-output LED matrix blasts parallel photons upward. This intense radiation penetrates opaque cellulose layers, projecting the structural blueprint flawlessly. The proportional divider, mathematical ratio locking. Transferring scale requires absolute geometric translation. This adjustable, double-ended caliper physically locks the mathematical ratio, transferring exact dimensional mass without computational error. The French curve, nonlinear geometric drafting. Biological forms lack straight lines. These engineered plastic templates utilize segments of the Euler spiral, allowing the artist to mathematically trace flawless, accelerating curves with zero deviation. The drafting compass, absolute radial symmetry. Freehanding a perfect circle is biomechanically impossible. This metal instrument anchors a static pivot point, utilizing a rigid radius arm to mathematically scribe an unyielding geometric orbit. The Bristol board, compressed cellulose density. Standard paper buckles under liquid saturation. Bristol is manufactured under immense mechanical pressure, creating an unyielding multi-ply structural slab that permanently halts moisture from warping the geometric plane. Liquid frisket, hydrophobic polymer barricade. Preserving pure white paper requires a chemical shield. This liquid latex paints on, curing instantly into a hydrophobic rubber membrane. It completely repels liquid pigment before being violently peeled away. Low-tack drafting tape, structural surface preservation. Securing paper requires an adhesive that will not violently tear the microscopic cellulose lattice. This specialized tape utilizes a low-friction chemical tack, locking the paper without structural destruction. India ink, carbon black suspension. Standard inks fade under ultraviolet radiation. This ancient chemical formula suspends pure silt particulates in liquid shellac. Once dry, it polymerizes into an unyielding, waterproof, absolute black structural resin. The steel flex nib, capillary reservoir dynamics. Dipping this forged steel tip creates a temporary microscopic fluid reservoir. As downward kinetic pressure spreads the metal tines, it violently breaks fluid tension, releasing the ink. The electromagnetic stylus, battery-free kinetic translation. An internal copper coil interacts with the tablet's magnetic field, converting biomechanical motion into instantaneous digital geometry. The pen display. Direct photonic interface. By drawing directly on a laminated glass matrix, the artist eliminates parallax error, achieving mathematically perfect spatial coordination. The micro-pressure sensor. Digital weight calibration. A microscopic spring in the pen tip calculates thousands of pressure levels, translating physical force into exact pixel opacity. The friction glove. Biomechanical rejection. Bare skin generates electrical capacitance, causing digital errors. This synthetic sleeve completely blocks false touch data while eliminating surface friction. Non-destructive layers. Optical stacking. Digital drawing allows infinite transparent planes. You construct structural geometry on base layers without ever permanently destroying the final rendering. The algorithmic architectural locking. Software calculates mathematically flawless vanishing points, snapping hand-drawn vectors to an unyielding three-dimensional geometric wireframe. Chromatic blending modes. Algorithmic light addition. Instead of physically mixing pigments, the software calculates exact math, instantly multiplying or subtracting RGB values for perfect shadows. Vector pathways. Resolution-independent geometry. Unlike static pixels, vectors use mathematical formulas to plot curves, allowing infinite zooming without any structural degradation of the line. The hexadecimal color picker. Absolute chromatic accuracy. Artists do not guess colors digitally. They select exact numeric codes, guaranteeing mathematically flawless optical reproduction every time. Pixel density. Structural canvas resolution. A high DPI canvas creates a massive geometric grid of microscopic pixels, providing the absolute minimum density required for photorealistic rendering. The matte screen protector. Synthetic paper tooth. Drawing on glass causes uncontrolled kinetic slipping. This textured film introduces microabrasions, replicating the exact frictional coefficient of paper. The ergonomic stand. Biomechanical spine alignment. Drawing flat destroys cervical vertebrae. Elevating the canvas locks the artist's body into a sustainable, mathematically optimized kinetic posture. The RGB color gamut. Optical wavelength expansion. A screen physically emits light, unlocking brilliant, hypersaturated neon wavelengths that traditional pigment absorption can never mathematically achieve. Replacement stylus nibs. Friction degradation. The kinetic friction between the plastic tip and the textured screen causes microscopic structural wear, requiring regular replacement to maintain precision. The reference monitor. Dual optical processing. Artists must anchor their work in reality. A secondary screen provides high-fidelity, unyielding photonic data to mathematically copy real-world lighting.